Hi, ArcfieldWeather.com meteorologist Paul Dorian here. We're approaching the middle part of the month of October. It's time once again to take a look ahead to what kind of factors can influence the weather conditions this upcoming winter in the mid-Atlantic region in the northeast U.S. and really elsewhere across the nation as well. Right off the bat, let me point out some of the key factors that I've focused in on in preparing for this winter outlook. And number one, it's the third winter in a row featuring La Nina conditions in the equatorial part of the Pacific Ocean. La Nina suggests water temperatures are below normal, and it looks like that will not only continue this winter, but will be in existence for the third winter in a row, back to back to back La Ninas. I've looked back over the past 50 years or so and found only about 3 such cases here, and I've taken a look at some of the analog years, citing most specifically that third winter in a back-to-back-to-back La Nina episode. In addition, we have kind of an interesting situation for the first time in doing a winter outlook where a volcanic eruption can actually play a role. Many of you may remember the massive volcanic eruption way back in January of this year, January 2022, in the South Pacific. That particular volcanic eruption injected massive amounts of water vapor into the stratosphere across the southern hemisphere, led to a stratosphere cooling time period. And I've taken a look at another set of analog years, not only with respect to the third La Nina winter in a back-to-back-to-back episode, but also in those particular years where there was stratospheric cooling featured in the southern hemisphere, let's say during the spring, summer, and fall season. The subsequent winter in the northern hemisphere has had kind of an interesting impact, and we'll get into that over the next several minutes or so. And as always with a La Nina type of pattern here, there's a southeastern ridge that will likely play a role. At times it'll strengthen and maybe move some warmer air up the coast. At other times it'll kind of weaken and be suppressed down to the southeast. But certainly another thing to look at will be the possibility of a ridge over the southeastern part of the country, which is rather typical of a La Nina winter. Well, first and foremost, I take a look at sea surface temperatures whenever dealing with a long-range outlook. I want to take a look at sea surface temperatures around the globe. And by the way, all these maps I'm showing in this video discussion and the text as well, right there on the homepage of the ArcfieldWeather.com website. So certainly you can go back and take a look later on at all of these plots and tables that I will be showing over the next several minutes. And there's a few more that I won't go over in the video discussion, but this is certainly a key one here. Sea surface temperature anomalies just recently as we're going into the middle part of the fall season. This is the equator right here, this horizontal line right here. It stretches all the way across, and not hard to see, not this colder than normal blob of water here extending off the west coast of South America, all across the equatorial part of the Pacific Ocean. That represents the La Nina conditions for the third winter in a row. Now notice also there's a lot of warmer than normal temperatures in terms of the water, northern Pacific, across the Atlantic Ocean. They'll play key roles as well, but this first and foremost is of importance here. It's the third winter back to back to back. Only happened about 3 times in the past 50 years or so. The last time the third winter was 2000, 2001. Before that, 1985, 1986. Before that, 1975, 1976. So I've kind of used those analog years. And again, that's the third winter in that back-to-back-to-back La Nina episode. Well, let's go over a couple of plots that suggest there are strong reasons to believe La Nina will not only continue over the next several weeks, but probably the next several months as well. First, we'll take a look here at a compilation of computer forecast models. There's a couple different types of computer forecast models. Dynamical models, which really involve current conditions, and then there's statistical models that, based on statistical analysis, come up with a prediction as in terms of sea surface temperature anomalies. And this is the forecast from a whole range of these computer forecast models. And the key points to look at here, the key places to look right here, this is what we call kind of the neutral zone. Anything above represents El Nino conditions, warmer than normal in the tropical Pacific. Anything below that neutral line, La Nina conditions, colder than normal. Certainly falling into the camp once again for La Nina conditions. This is the observation period right here, and then anything to the right of that is the forecast, and we have almost all of these computer forecast models remain below the neutral line. This is the rolling 3-month period of December, January, and February, so the heart of the winter season right here. And again, the vast majority of these computer forecast models, either dynamical or statistical, suggest La Nina will continue certainly right into the spring season of 2023. The red represents the average of all the dynamical models, and the green line right here of the average of the statistical models. Again, both below the neutral line, both suggesting La Nina conditions will continue through the upcoming winter season. Well, let's just briefly take a look at one of those models, one particular model. This is just an example here of forecast of La Nina in the upcoming winter. This is actually NOAA's climate forecast system model, and again, this is the equator latitude right here, 0 degrees, and South America, the west coast of South America, and this is the forecast for this time period by this particular model, just one of those compilation of models that we saw the plot a moment ago. La Nina conditions right here in the equatorial part of the Pacific Ocean, with warmer than normal conditions in the North Pacific and warmer than normal conditions in the North Atlantic. But again, this is just one of several models suggesting La Nina will certainly continue for the next few months. Well, I certainly don't just look at model forecasts. I like to look at current observations to try to find some supporting evidence for another winter of La Nina. This, I believe, suggests, the current observations suggest La Nina is certainly in the cards once again. What we're looking at are temperature anomalies from the surface of the ocean, which is right here, and then all areas below the surface. So we're going down deeper and deeper across this kind of longitude zone. This area right in here represents roughly the Pacific Ocean, and you can see a lot of colder than normal water just beneath the surface over the Pacific Ocean. Again, places like 100 degrees west, 120 degrees west, 140 degrees west. This is roughly where the Pacific Ocean lies, and a lot of colder than normal water just beneath the surface as we go into the middle part of the month of October. And that tends to bubble up to the surface, and indeed this is supportive evidence. It certainly has in the past tended to be quite well correlated with an upcoming winter season, La Nina winter season, let's say 1 or 2 months later. So a lot of colder than normal conditions. So again, computer forecast model suggests La Nina will continue, and the current observations of sea surface temperature anomalies in the Pacific Ocean really show a lot of colder than normal water just beneath the surface. That too is a supportive case to suggest La Nina will continue this upcoming winter season. Well, now that we have provided some evidence that La Nina should very well continue this winter season, let's take a look here at this particular graphic that pretty well represents what a typical La Nina winter pattern has to offer. Now, no two La Nina winters are the same. Certainly there's always some differences somewhere along the way, but there's a few highlights here I want to point out. First of all, tend to have a strong northern jet, what we call the polar jet, and that tends to bring in colder than normal air from, let's say, western Canada, even Alaska, all the way into the interior northwestern part of the nation, the northern plains. And weather makes it all the way into the mid-Atlantic region is really 50-50. Some La Nina winters feature colder than normal conditions all the way into the mid-Atlantic and the northeast U.S. Others do not. I tend to lean towards, yes, this winter will be colder than normal in the mid-Atlantic region. We'll highlight that later on here. Certainly the northern plains and places like Montana typically have a colder than normal winter, and I do believe that will be the case again the third La Nina in a row. Also, we tend to have a ridge of high pressure in the upper part of the atmosphere in a La Nina winter over the southeastern part of the nation. It certainly can fluctuate in intensity and specific location, but overall there tends to be a ridge in the southeastern states during a La Nina winter. That'll kind of cause a battleground up in the mid-Atlantic region. Sometimes that ridge intensifies and it brings some milder air up the coast. Other times it tends to be suppressed and colder air can move into the mid-Atlantic region, the northeast U.S. from the Great Lakes. Also typical, not only do we have this polar jet oftentimes in a La Nina winter, but we basically have dry and warm conditions extending across the southern states from California, at least the southern half of California, across Texas into Florida, partly as a result of the southeastern U.S. ridge that oftentimes sets up position in a La Nina winter. Well, let's now take a look at some analog years. I always try to look to the past for winter seasons that kind of feature some of the same kind of conditions. Again, no two winters are alike, but this year looks like another La Nina winter, and in this particular case I focused in on the third winter in a back-to-back-to-back La Nina episode, because that is indeed what we're going to experience this year. And again, about 3 different winter seasons in the past 50 years or so, the last one being 2000 and 2001. Before that, 85-86 was the third winter season, 75-76. If you take a look at the temperature pattern, the temperature anomaly pattern across the U.S. for those 3 winter seasons, kind of a clear signal jumps out at you with colder than normal conditions in the eastern half of the nation. Again, this is for the whole winter season, December, January, February, and March, based on those 3 analog years. So colder than normal conditions in those particular third winters of a back-to-back-to-back La Nina episode. Now, how about the precipitation pattern? Let's just go down a little bit here. And again, all these maps and plots are right there on the arcfieldweather.com website, so certainly can go back and take a look at them later on, and they'll be under our seasonal outlook page shortly. Basically in the mid-Atlantic region, northeast U.S., near normal to maybe slightly above normal, below normal precipitation anomalies, and this is leading me to believe we may have near normal snowfall amounts. Places like D.C., Philadelphia, New York City, maybe a little bit above that, but again, generally near normal precipitation in those particular 3 analog years, and again, below normal in Florida, Texas, and basically near normal throughout the southern and much of the northern half of the nation as well in those particular 3 seasons, and quite a bit below normal across the west coast. Well, one thing of interest too, I just showed the December to March time period for those 3 analog years, and I wanted to take a look at a month-to-month basis, and this is one thing that's pretty interesting to say the least. This is just for the month of December in those particular analog years, and cold. Eastern 2/3 of the nation for the month of December, suggesting we could very well get off to kind of a quick start in the mid-Atlantic region, in the northeast U.S. with winter-like cold, colder than normal conditions during the month of December, as is typical for these kind of third winters in the La Nina back-to-back-to-back episode. We've often had, in recent years, warmer than normal Decembers, maybe colder than normal Aprils. This is suggesting we certainly could have a quick start, maybe any time after Thanksgiving leading up to the holidays. We could have some colder than normal conditions, which will perhaps include some accumulating snow in the mid-Atlantic region and the northeast U.S. So an interesting finding by using those particular analog years. Well, let's now revisit that Tonga volcanic eruption that took place in the middle of January back in this year, earlier in 2022. It was basically what we call a submarine volcanic eruption that was in the southern part of the Pacific Ocean, and it injected massive amounts of water vapor way up into the atmosphere at the stratospheric level over the southern hemisphere, and that in turn tended to act as an inhibitor for sunlight to reach the upper part of the atmosphere, kind of reflecting sunlight away at the upper part of the atmosphere, reflecting it back into space, and it led to a significant stratospheric cooling in the southern part of in the southern hemisphere during the subsequent spring, summer, and even into the fall seasons. And took a look at some analog years where there was indeed significant stratospheric cooling in the southern hemisphere earlier in a given year to see what kind of impact it may have had on the northern hemisphere winter. And indeed, it resulted in a lot of high latitude blocking with higher heights to normal focused in over places like Greenland. So again, this is suggesting that because of this impact of the volcanic eruption that again took place way back in January, we could actually have more frequent high latitude blocking or a negative NAO type of pattern during the upcoming winter season in the northern hemisphere. So let's take a look here. What we saw in August, this is the temperature anomaly in August of this summer season, with dark blue showing up here throughout the southern hemisphere. Again, this is partly, maybe mostly, a result of that injection of massive amounts of water vapor way up in the top of the atmosphere. Again, keeping the lid on how much the sun could warm the upper part of the atmosphere. So significant stratospheric cooling over the southern hemisphere during the summer season. Now let's take a look at those analog years and what kind of 500 millibar height anomaly pattern followed in the subsequent winter season in the northern hemisphere. And here it is. Again, I went back in time, found some years where there was stratospheric cooling, significant stratospheric cooling in prior summer months to a winter season that followed. And this is the 500 millibar height anomaly pattern for that following winter season of December, January, and February. And this just jumps out at you right here. This is higher heights than normal over Greenland, over the northeastern part of Canada. This is, in other words, a kind of a negative NAO type of pattern here with at least on average a higher heights to normal, higher pressures than normal, high latitude blocking, if you will, over Greenland in these stratospheric cooling years across the southern hemisphere. Again, we're talking about what kind of impact that had on the following winter. So this is suggestive of high latitude blocking. Now, high latitude blocking, as we often talk about during the winter season in the Mid-Atlantic region, tends to increase the chances for cold air outbreaks from central Canada to reach the central and eastern part of the U.S. and it tends to increase the chances for what we call sustained cold air outbreaks. You really need sustained cold air, especially in the I-95 corridor region. If you don't have sustained cold air backed up, supported by high latitude blocking, you can have a snow changing to rain situation, especially in the urban areas in the DC, Philadelphia, New York City, Boston corridor. But if you have high latitude blocking with very strong high pressure sitting over Greenland, you can not only have cold air outbreaks into the Mid-Atlantic, into the Northeast U.S., but you could have sustained cold air, which is a critical requirement for accumulating snow in that I-95 corridor. Again, this set of analog years related to stratospheric cooling in the southern hemisphere suggests we could have more frequent than normal high latitude blocking events this upcoming winter season. Well, let's get to the bottom line then. How does all this translate into the upcoming winter season for the Mid-Atlantic region, the Northeast U.S., and the rest of the country as far as that goes, because of the analog years suggesting, well, not only the analog years for the third winter in a back-to-back-to-back La Nina event, but also the analog years related to stratospheric cooling in the southern hemisphere and high latitude blocking, increased chance of high latitude blocking. I believe we'll have colder than normal conditions in the mid-Atlantic and northeast U.S. for this upcoming winter season, perhaps on the order of 1 to 3 degrees below normal for the entire winter season. And the season could get off to a quick start with colder than normal conditions as early as the month of December. Perhaps even the time period from Thanksgiving Day to Christmas Day could be colder than normal, and that could certainly lead to some snowfall before the holiday season at the end of the year. In terms of snowfall, I believe we'll have near normal to maybe slightly above normal snowfall amounts in the D.C., Philadelphia, New York City region, with the listed amounts right here. But again, an analog year suggests near normal precipitation. That could lead to near normal, maybe even slightly above normal snowfall amounts. Elsewhere across the country, as is typical of a La Nina winter, likely to have that persistent northern polar jet bringing colder than normal air masses into the interior northwest, into the northern plains, places like Montana, Minnesota, likely to have colder than normal winter season. And again, I think more often than not, those cold air outbreaks will make it all the way into the northeastern quadrant of the nation. And as is also typical of La Nina, likely to have warmer, drier conditions across much of the southern U.S., let's say from southern California to Texas to Florida. Oftentimes there'll be a southeastern ridge located over places like Florida or Georgia during the upcoming La Nina winter. So that's it for now. We'll certainly continue to monitor all of these factors over the next several weeks, but that's the winter outlook for 2022-2023 from Arcfield Weather. That's it for now. Talk to you all later.